children. In the previous session, we learned about how we can see objects when light is present by learning about light. We also learned about the types of objects and shadows. Now, in this session, we will understand the nature of the straight line motion of light by learning about pinhole camera. And we will also learn about the mirrors and reflections from the lesson Light, Shadows and Reflections, Class 6 Science. Learning outcomes. At the end of this session, you will be able to understand about pinhole camera, difference between image and shadow, mirrors and reflections. Keywords. Pinhole camera. A simple camera without a lens but with a tiny hole. Shadow. An area of darkness formed by an opaque object obstructing light. Mirror. Image. Reflection. The bouncing back of light from any shiny surface. Before starting the session, let us look at the concept map of this session. The nature of the straight line motion of light can also be understood by a pinhole camera. With this camera, we can observe a big object through a pinhole. Now, let's see how to make a pinhole camera. For this, take two PVC pipes such that one can slide into another. Cut a piece of black paper and put it like a cap at one end of the big PVC pipe and fix it with a rubber band. Put the white paper like a cap at one end of the thinner PVC pipe and fix it with a rubber band. Now, make a hole in the middle of the black paper cap with the help of a pin. Put 2 to 3 drops of oil on the white paper cap so that it becomes translucent. Insert the thin pipe into the big pipe. Our pinhole camera is ready now. Put a lighted candle in front of the pinhole of the camera. Holding the pinhole camera, look through the back side of the thin pipe. Now, move the thinner pipe forward and backward to get a clear picture of the candle on the screen of the thin pipe. We observe that the candle's flame appears inverted on the screen because it is its image. The light from the candle travels straight in all directions from each point of the candle's flame. But only the light coming in some particular direction can enter the camera through its pinhole, and the light in other direction is blocked by the black sheet. Light, which comes from the point at the top of the flame, goes straight towards the bottom of the screen. And light, which comes from the point at the bottom of the flame, goes straight towards the top of the screen. This leads to the formation of an inverted image. The formation of an inverted image on the screen of the pinhole camera explains that light travels in a straight line. Let us do an experiment to prove that light travels in a straight line. Take a long rubber tube, light a candle and fix it on a table at one end of the room. Now, look at the candle through the pipe. The candle is visible to us. Now, bend the tube a little while looking at the candle. The candle is not visible to us now. This suggests that light travels along a straight line. We see our face in the mirror every day. Is this picture in the mirror a shadow or an image? How do you decide that? We know that shadows are not colored, but an image has colors that are the same as that of the object. A shadow shows only the outline of the object, but an image shows the complete object as it is, just like a photograph. The shadow does not undergo lateral inversion, but the image undergoes lateral inversion, that is, left-right reversal. The shadow and the image of a tree are shown on the screen. We all use mirrors at home. We look into the mirror and see our face inside the mirror. What we see is a reflection of our face in the mirror. We also see reflections of the other objects that are in front of the mirror. Sometimes we see reflections of trees, buildings, and other objects in the water of a pond or a lake. Now, let us do an activity to understand mirrors and reflections. This activity should be done in a dark room. Ask one of your friends to hold a mirror in his hand. Take a torch and cover its glass with black paper. Make a thin slit in the middle. Now, switch on the torch and direct the beam of the torch light onto the mirror that your friend is holding. Ask your friend to adjust the mirror so that the patch of light falls on another friend standing in front of him at some distance. When light falls on the mirror, it rebounds back. This is called reflection. This activity also suggests that a mirror changes the direction of light that falls on it. Let us do another activity to understand mirrors and reflections. Fix a comb on one side of large thermocol sheet and fix a mirror on the other side. Spread a dark colored sheet of a paper between the mirror and the comb. Send a beam of light from a torch through the comb. We observe that the light is traveling in a straight line and getting reflected from a mirror. This activity gives us an idea of how light travels and gets reflected from a mirror. Points to remember. Light travels in a straight line. The nature of the straight line motion of light can also be understood by a pinhole camera. Light gets reflected when it falls on any object. A shadow shows only the outline of the object, but an image shows the complete object as it is, just like a photograph. The mirror changes the direction of light that falls on it. Mirror reflection gives us clear images.